Today we are going to look into the recursive problem of Tower of Hanoi. So basically there are three towers, Tower 1, Tower 2 and Tower 3, and there are three disks of different sizes kept on Tower 1. Now the problem statement is that we have to move disk from Tower 1 to Tower 3, and the constraints of the system are that only one disk can be moved at a time. Each move consists of taking the upper disk from one of the tower and placing it on the top of another tower. So this can be only moved if it is in the uppermost disk, right? And the third and the most important is that no disk can be placed over a smaller disk, right? So this is our Tower of Hanoi problem. So this is Tower 1, Tower 2, Tower 3, and again these are the three disks. So red is the smallest, green is the medium, and the yellow is the largest. So we will try to solve this problem first using two disks. So you see, only we have removed the red disk and there are only two disks at this moment, the green disk and the yellow disk. So the solution is, first we have to move the uppermost disk to 2, that is 1 to 2. We have moved disk from 1 to 2. Then we will move the Tower 1 disk to Tower 3 disk, that is 1 to 3. We have moved it. Lastly, we will move from disk 2 to disk 3, that is from disk 2 and to disk 3 we have moved it, right? Now, why is this problem recursive? Let us consider into our previous problem where we have considered only two disks. Now, let us consider the green disk, that is the topmost disk, as the n-1 disk. And what we did was, we will move n-1 disk from 1 to 2, move one disk from Tower 1 to 3, and move n-1 disk from 2 to 3. That is n-1 disk from 1 to 2, and the one most disk from 1 to 3, and n-1 disk from 2 to 3. So basically when you are using n-1 this time instead of 1, so basically we are taking up this problem as a recursive problem, right? Now what is the code of this problem? Now this n-1 can be recursively solved using can be recursively solved. So what is the C code of this problem? So void move int n in Tower x, in Tower z, in Tower y. So if there are n number of disks, so let us say there are 3 disks, so move 3 disks from Tower x to Tower z, that is Tower 1 to Tower 3 using Tower 2. If there is only one disk, if n equal to 1, we will move from Tower percentage to percentage, that is Tower 1 to Tower z, Tower x to Tower z, or 1 to 3. It can be 1 to 2 depending upon the state of the recursion. So again, this is the main, this is your main part of the problem. So if it is, if n disks are moved from Tower x to Tower z using Tower y, or Tower 1 to Tower 3 using Tower 2, then this is what is that. So if there are n disks, it will be n-1 disk, that is 3, if it is 3, it will become 2, that is 2 to move from Tower x to Tower y using Tower z. Because the problem was what? Tower 1 to Tower 3 using Tower 2. In this case, it will become what? Tower first, it will move 1 to 2 using 3. Then it will move the last disk, that is from 1 to 3. Then it will move the n-1 disk on Tower 2 to Tower 3 using Tower 1. So this is problem is recursively resolved. So if it is n minus disk 1 to 3 using 2, so then 2 disk n-1 disk from 1 to 2 using 3, move the last disk 1 to 3, and then move the n-1 disk from Tower 2 to Tower 3 using Tower 1. So let us solve using a recursion tree. So if this is our problem, that is we have this is move 3 disks from 1 to 3 using 2, that is Tower x is 1, Tower z is 3, and Tower y is 2. So it will recursively call this problem first, this equation first, that is 2 Tower x to Tower y, that is 1 to 2 using 3. 1 to 3 for 2 will call 1 to 2 using 3. So again 2 1 to 3 will call again another recursive function, that is 1 to 3 using 2. 1 to 2 using 3, we'll call 1 to 3 using 2. Since there is only one disk left, so it will be resolved automatically. So it will go back and again call this one. So this one is resolved since it has become 1. So one disk, so the one disk it will move from tower X to tower 3, and then it will go back and try to solve the right hand side equation. So left hand side we have resolved. So as you are coding it, it will only call the first above one. So above one will again call the above one. So when the above one resolves, it will solve the middle function, and then it will call the again the rightmost function. So 2123 has called 1132. This recursive call ends here. So this recursive call in this case ends here, right? It ends and it starts from here. So we'll mark it, and it again starts from right hand side in the next column. We'll see that. So 1 2 2 3 1 1 3 2 is solved. So it will call this one, that is 2 2 that is 3 2 1 2 2 using 3 1 2 3. Then we'll call 3 2. So tower X is 3, tower Z is 2, and tower Y is 1. So this has been resolved. This is resolved. This is resolved. This is resolved. So this one is also resolved. So again, this function will call from the right hand side function of this one. So 3132 will call 2231, right? And 2231 will again call 1213. That is, move this 2 to 3 will call from 2 to 1 using 3. And when this is this one, it is resolved. So it will call from 1 to 3 using 3. So we have mentioned all the towers in this tab. So we have reached our final solution in here. Okay. So now let us solve it. Let us get one of the data one by one. So we'll call from the leaf of the node, since it is calling from left hand side only. So it will call from left, root, and then right. So left one is called 1 to 3. Then it will call this one. So it will print this one, that is 1 to 2. Then again we will call left. Then it will resolve the second line, that is 1 to 2, and then we go to the third line, that is 3 to 2. So in here, I'll just let you know. When 212 calls 3, so basically the first 1132 is called first. Okay, then 2123 is basically represented by this function. And lastly, when I am calling 111321, so this is called by this function. Okay, so it is printing. So this is basically the first leaf node. Then this will print this one. Printf is this one. Then this is the right. That is the right call is basically represented by this one. We will see to this next one. So it is called this one. So 1 2 3, then 1 2 2, then 3 2 2. Then it will call the root of this call. So it is calling 1 2 3. Then again it will go into the left hand side to see which one to call first. It will call 2 to 1. Then it will go to the call the middle function, that is the printf 2 to 3. And finally it will call 1 to 3, that is the rightmost recursion call. Okay, so let us solve. So this is your solution. So this is your solution. Let us solve is using the actual tower of Hanoi. So this is your tower of Hanoi, 1 2 3, and let us move one disk at a time. So first one is called 1 2 3. So we'll move the red upper disk from tower 1 to tower 3. Move. Then 1 2 2. Move. green from 1 to 2. Then red from 3 to 2. Red is moved from 3 to 2. Then 2 to 1. That is we have moved from this 1 to this 3. And then we'll move from this 2 to this 1. That is red from this 2 to this 1. Then we'll move from this 2 to this 3. That is green from this 2 to this 3. Lastly, we'll move from this 1 to this 3. That is red to upper 1. So we have solved the Tower of Hanoi problem using recursion. So the assignment you see is prepare a recursion tree for number of bits equal to 4. Thank you.